Let's talk about file I/O. What does I/O mean? You'll see this a lot in programming. I/O stands for input output. You see, most of the times, machines are not communicating in just one environment. For example, so far we've been writing our code in, let's say, an editor like Sublime Text that I have here, or PyCharm, or an online REPL. But usually you want to interact with different parts of the system. Maybe you want to speak to another website. Maybe you want to speak to something that's on your desktop, maybe a file. Maybe two different machines are communicating with each other. Maybe you're speaking to a database. I/O simply means, hey, I want you to input something from the outside world and output something into the outside world. And one of the most common ways that we use things like I/O is through reading files. You might think about Python and how wouldn't it be nice if we can perhaps write a script that compresses images? Well, we need I/O then. I need to input an image, and then I need to output the compressed image. Maybe I want to work with a PDF file and maybe add a watermark to all my PDF pages. Well, then we input a PDF and output a new version of a PDF. So this is a very common task that we see a lot of. And reading and writing files is a very important tool in our tool belt. And by the way, we have a project coming up where we actually are going to use this with PDFs. But for now, how can we do this file input-output with Python? Well, Python has a built-in function that allows us to open and write to files. And it's simply called open. Nice and easy. So using open, we can do something like this. I can create a sample text file in our desktop. So I'm going to use my terminal here. So if we look at present working directory, I'm on a desktop. If you're on Windows, then you might have to do some different commands in here. But by now, you should be pretty familiar that you can create a file if you wanted to. Now, I can do this manually, or in my terminal, I can actually do, if you're on a Mac, you can just do touch, and then I'll say test.txt. So if I do ls here, you see that I have a test.txt file and a script.py file. And again, just to double check, if I go to my desktop, yep, I have these two right here. Perfect. Now, in here, we can simply say, in our script file, open, and the name of the file. In our case, it's test. Make sure it's string test.txt, just like that. Now, I can assign this to a variable, calling it my file. And now we have, well, the file object. So let's check this out. If I do here, print my file, let's see what happens. I'm going to run my code. So let's say Python 3, and then run script.py. All right. I get an object, a text IO wrapper. I get the name, which is text. I get mode, which I'm not sure what it is yet. We'll learn. And then encodings, which is how this file is encoded, which is UTF-8. Most of the files are usually encoded in UTF-8. All right, so how can I actually read this file? All we need to do is my file has a .read method on it. So that if I run this now, well, I get a blank piece of space because there's nothing on this test.txt file. So let's write something. I'll open this file in Sublime Text and just write, hi, my name is Andre Nagoy. I got really, really creative with this one. Good job. All right, let's go back. So now if I read this file, look at that. I'm able to read, hi, my name is Andre. And now, there you go. I've read my file. Nice and easy. Now, if I run this again, let's just read this multiple times. If I click run, I'm able to read the first time around, but these two times, I'm not reading anything. Why is that? Well, this open function has this idea of a cursor. That is, you can only read the file once. And once you open, it returns a file object, and the contents of the file you can read. And the contents of the file are read with a cursor, just like you see here, one by one and printed onto the screen. But by the end of this first reading, the cursor is going to be at the end of the file. So now when it tries to read, it's going to be end of the file and nothing will be left there. So the way we get around this is to do something like this. We simply say myFile.seek, which moves our cursor to whatever index we want. In our case, seek 0. So if I run this now, there you go. And if I move the cursor back and I save and run this, all right, that's a lot better now. And this is just to demonstrate that Python uses this idea of a cursor to read a file. Now, another unique thing that I can do is to do read line. So that if I run this, it reads the line, but let's say our text file has different lines. So how are you? Let's say a smiley face in here. If I now read the line, I get, hi, my name is Andre. If I read the line again, hi, my name is Andre, because I get each line. I only get the first line. If I print this multiple times and I run this, all right, that's better. I get, hi, my name is Andre, smiley face, how are you? Again, the cursor keeps moving, right? So I can just keep reading the lines. Another thing that I can do is to just say read lines. If I run this, I get a list that contains the entire file, reads all the lines, and you see here that I have, hi, my name is Andre Nagoy. I have a new line here, a smiley face, a new line. Remember, this is escape sequencing. And then, how are you? And no new line here because there's no new line. It's the end of the file. So these are extremely useful. Maybe we can use regular expressions to search for a piece of text in a file. That's pretty useful, right? Now, the very last thing we need to do, and this is a little annoying, so I'll show you how we don't need to do it in the future. But you actually have to manually close the file after you've opened it with open, so you can use it somewhere else in the program. It's just a good standard. So what you have to do is say myFile.close after you're done with it. You tell your computer, hey, you need to stop whatever you're doing. I'm not interested in the file anymore. We're done with it. You can use it somewhere else. So usually we do something like this and we're all done. Let's take a break and learn some more in the next video. Up until this point, we've learned how to read files. But we had this annoying thing with the cursor, and then we had to close the file. So how can we fix this? Well, a better way to actually do something like this and do file I/O with Python is with the built-in with statement. Let me show you. Instead of what we had before, what we're going to say is with open the name of the file and say as whatever the variable you want. So my file. So now with open, you can actually do something like this, but you don't have to worry about closing. So most of the time, you want to use the with statement. This is the proper way to work with files in Python. And if I save here and run my script, oh, I get an error because I forgot the column here. If I run again, there you go. I get my output, and I don't need to close my file. Everything is done for me. So this is a standard way to read a file. Now, what if we wanted to write to a file? So far, we've only read. And actually, underneath the hood, open has a default parameter called mode equals to R, which stands for read. So with mode R, we are able to read files. When we don't specify the mode, it automatically just assumes we're reading. But if we wanted to write to a file, we can simply do W for write. So if I run this, you see that I get an error now, unsupported operation, not readable, because, well, the file can only be written. So in order for me to read and write, I can write RW, right? Well, let's see. Nope, that's actually not how it works. You would think it'll be RW, but this is a bit of a trick. In order to read and write, we do read plus. So that if I run this, all right, I'm reading and writing. And I get an empty list because this is now empty. Okay, so let's write to a file here. Let's make this a little bit smaller just so we can see. That's better. Let's say that in this file, I want to have text. And in this text, I'm going to say my file dot write. And I can write whatever piece of text I want. So let's say, hey, it's me. So now in here, if I do print text and I run this, I get 11. What is this 11? Well, this isn't really important right now. What we want to focus on is, hey, it's me. I've written to a file. Okay, so let's say I wanted to open the file again and actually write again. Let's say this time around, I'm going to write a smiley face. If I run this and go back, all right, it looks like I wrote to the file, but is this what we wanted? When we write something to a file, the cursor resets. Remember, when we open a file, the cursor goes to 0, and we write to the file. And if there's something already existing in there, well, we overwrite it. So we have to be careful. And by the way, this text file just gave us that we wrote 2 characters, the smiley face. Okay, so how can we fix this? How can we make sure that we don't break what we had previously, which is, hey, it's me, and I just want to add a smiley face at the end? Well, we can use the append mode. The append mode is A, and this appends to the end of the file. If I run this, look at that. Hey, it's me with a smiley face. It appends to the end. So that's the append mode. Again, we can use W to write, and if I run this, it adds a smiley face. Now, why did it not do like last time and overwrite the existing thing? Well, it's because of our mode. W allows us to write to a file. Previously, when we did read and write, what happened was we read the file. Let's run this again. Actually, let's go back to, hey, it's me, the way it was. And if I run this again, because we did read and write, the cursor was set to 0 and overwrote it. Versus if we just did the write, it will assume this is a new file and we just want to, well, just add the smiley face. If I click run here, you see that now is just smiley face. So you want to be careful that you use the right mode based on what you need. Now, let's say we wanted to create a file that doesn't exist. Let's have a file called happy.txt. Or actually, no, let's do sad. And this writes a sad face. But remember, we don't have this on our desktop. If I clear this and look at our desktop, we don't have a sad.txt. If I do read plus here, so read and write, and I run this, I get a file not found error. if I do a write here and I run this, all right, it looks like it worked. If I look at the files, I have a sad text now. So now if I open it, I have a sad face text. So write also creates a new file if it doesn't exist already or overwrites the existing one. So you want to be careful once again with the mode, whether you want to append, whether you want to read, whether you want to read and write. But most of the time, the most common ones are read, write, and append. Now, in the next video, I want to talk about this idea of a file. I've written text files for now, but we could have written anything. We could have done a .py file if I wanted to. But what about accessing files that are in different locations, such as inside of folders? We're going to explore that topic in the next video. I want to talk quickly about file paths, because for some people, this might be a new concept. Up until now, I wrote, let's say something like sad.py or sad.txt, and I was able to run this code because when I ran it in my terminal or command prompt, they were all in the same folder on my desktop. If I do present working directory on a Mac, it shows me where I'm currently at, which is the desktop. So I was able to run it like this because my script file was in the same folder as my sad and test text. But what happens if this wasn't the case? We can actually jump back a directory by saying cd ... So if we go back, my present working directory is now user Anagoy. So I'm not on the desktop anymore. So that if I try and run Python 3 and then say script.py, well, can't find the file, right? So let's go back to desktop and try to figure out this problem. I'm going to, for now, make a directory and call it, let's say, well, a very generic folder, or let's just call it app. So now I have an app folder. I can move this sad text into the app folder now. So if I grab the sad text and move it to the app folder, if I go back now and try to access sad.txt, so let's say Python 3 script.py, well, if I go back, I've appended sad.txt, so it's actually creating it for me. So instead, let's actually remove sad.txt because we actually have one already in here in the app. Instead of appending it, let's just do a read. If I try to read now, I get a file not found error. Sad.txt doesn't exist because it checks the desktop. And on the desktop, we have nothing. We don't have sad.txt. So how can we get around this? Well, I simply say that I want to go into the directory app/sad.txt. So that if I run this, now it's reading it, but it's an unsupported operation. So let's just turn this into a read. And we don't need any of this, so let's just print read here. If I run this, all right, it's working now. I'm able to change the file path. Now, if you're on a non-Unix based system, that is, if you're not on a Mac or Linux and you're on Windows, most of the time, instead of this slash, it's a backslash, like this. So Windows and Unix systems have different file paths and file system in place. So this is something that you can read up on. Depending on your file path and what your present working directory is, you'll have a better idea of how it should look. On Windows, it's usually something like C and then backslash, and then you'll have different file paths. Now, this is called a relative path. So relative to where I am, where I'm running the script from, I am going to go from here into the app into sad.txt. I could have also copied this entire file path like this. And this is called an absolute path. So if I run this, this still works because I'm giving it an absolute path. It's saying, hey, on this computer, this exists from the root user all the way into here. So this is another way of doing it. Most of the time you'll see relative because it's a lot simpler. Finally, you might sometimes see something like a dot slash. Dot slash simply means from the current folder. So if I run this, it's still going to work. It's going to say, hey, from the current folder, go to app folder, then go to the text folder. If I do dot dot slash like this, if I run this, I'll get an error. Dot dot means back a folder. So instead of our present working directory being desktop, because we did dot dot, we'll actually go into my user account and it's going to try and find anagoye/app/sad.txt, which is not going to find. Anyway, this is a bit of a tangent, but I wanted to let you know that these file paths are important and it's really dependent on what operating system you're using, like Mac or Windows, and also where you're calling the file from. Let's continue our discussion of files in the next video. One quick note that I forgot to mention, there's a really useful built-in module in Python, and you can see here it's new in version 3.4, called pathlib. It's an object-oriented file system path. Now, the main thing is you can see how to use it through the documentation, but the key thing is that if you're building a program that, let's say, reads something from the file system, like a file, and this program can be used both on Windows and Mac and Linux systems, you want a way to make sure that it works on both, right? Because we saw how Mac and Windows have different file system with different slashes. Well, pathlib library actually works with both. You can see over here, if you want to manipulate Windows path on a Unix machine or vice versa, this is going to work for you. And it's a good way for you to create software that is compatible with both systems because pathlib is going to take care of the file paths for you based on what machine is running your code. Now, this is something you can read on your own and experiment, but I wanted to let you know that this does exist and it is a useful library for you to have in the back of your pocket. That's it for now. I'll see you in the next one. Bye-bye. Welcome back. One of the common patterns when working with files is to actually put them in a try except block. So in here, we can say try and actually put them like this. And try out to see if the file exists. So we can say except, and let's say file not found error, which we've seen before. And here I can say as error, and inside we'll say print file does not exist. So that now if I run this, and remember in our current directory, we don't have sad.txt. If I run this, I get an error, file does not exist. We can even raise this error if we wanted to. So we can say raise error. So now it works as expected. I'll get file does not exist and then give a file not found error. So this is a common way to work with files to handle different errors. Another common one with files is this idea of an I/O error. And an I/O error usually happens when the computer or the machine you're on has some issue reading or writing or doing any sort of I/O operation. So you can have something like I/O error in here and raise that error if you want. Again, if I run this, file not found error. If for some reason I give it a weird mode to do, I get an unsupported operation error. The options are endless, but I hope by now you have an idea of how to do file I/O. But let's do a fun exercise because up until now, we haven't really done anything exciting. We just read a bunch of text from a file and that was it. Nothing that creator, right? So let's do something fun. In the next video, we're going to try and build a translator. That's right. I'll see you in the next video. All right, it's time for an exercise. And I think this is going to be fun. I want to use what we've learned up until now to build a translator. Let's say somebody gives you a massive text file. I mean, in our case, this is going to be the text file, but you can grab any text file that you want. It doesn't have to be a text file. It can be anything. It could be a PY file. It could be just a Word document. And type in a bunch of sentences in here, whatever you want, and just save it. In my case, I just have this. Now, somebody just told you, hey, I want you to translate this into, let's say, Japanese. Based on what you just learned about modules and files in Python, can you build a tool that allows us to run a command through that file, read it, and then translate it into Japanese? Now, if you really want to get challenged, you can pause the video and try it out. Or if you want a hint what module or library to use, well then keep watching, because I'm going to show you the recommended package to use. Okay, so what I actually did was I Googled Python offline translate using the PyPy index. Now I wanted an offline translation service because if you look, there's something like Google Translation that you can do. But what that does is actually make a call to the Google servers to do Google Translate for you. And that gets pretty complicated when we talk about APIs and API keys, something that we're going to worry about later on in the course. I wanted something offline, so I can download the translation service offline and just be able to use it right here. So the one that I found was, as I was Googling, I think it was called this one. Yeah. So this is just a translation service. It looks like it has some stars and forks on GitHub. So I always like that. I always like checking out their repository. So translate Python. Everything looks good. You can read about the documentation here. Hasn't been updated in 2 years really, but you know what? It's not that bad. It'll do the job. So using this package, you can try and read through the documentation and see if you can figure out how to solve this problem of translating that file into Japanese. You can pause the video here, give it a go. Otherwise, I'm going to provide the answer. Now, the first thing I'm going to do is before I even install this, I want to make sure I can read this file. So once again, I'm going to say try, and I'll have a file with open. We'll see where the file is. Let's say ls. We have the test file right in here, so we can just do // and say test.txt. And then I'll say as my file. We'll add the mode as read for now because we just want to read the file. But at least this way we're being explicit and we're saying, hey, this is exactly what we want to do. And then finally, I'll just, for now, print my file just to know that it's working. And we'll add some exceptions in here. It's except, not exception. And we can just, let's say, do file not found, error. We'll say as E. And we'll just for fun say here, print, check your file path, silly. And leave it at that. If I run this code, let's say Python 3 script.py. All right, I have my name is Andre. Awesome. Let's install the package. So over here, I can see that I have to install translate. That's what the package is called. Now, I'll use pip3 in my case to make sure that I'm using the Python version 3 and say install translate. Now, I've actually done this before just because, well, I tested this out beforehand, so it's already installed. So let's clear that out and read about how we can use this package. So you can see here the usage. So I can use it from the command line. Okay, that's interesting, but I want to use it as a module. Okay, here you go. Use as a Python module. So it shows you exactly what to do. So we import it first. So let's do that. I'm going to import this library. All right, so now we have the translator, and we can use the translator like this. All right, so we have the translator. So we create the translator class, and we want to say to what language. All right, what languages are available? Let's go to the read the docs here for documentation and see if they have Japanese in here. All right, let's see. Search docs, Japanese. All right, that doesn't help us. Let's look at overview. And by the way, I'm showing you the thought process that I usually have when I look through things, because sometimes people show you what the answer is without showing you the process. So hopefully this is useful. Okay, so I'm looking through here. It doesn't look like they're providing a list of languages, although, oh, I see it here, available languages. It looks like we're using this Wikipedia page as a reference. And oh yeah, these are the short terms for the languages that it's using. All right. So based on this, it looks like this is the standard that they're using, but actually while reading the documentation, I see that there's a JA. I'm assuming this is Japanese. So let's do that. I'm going to say JA. All right. And then let's see, go back to the documentation here. Let's look at overview. Let's go back actually. Okay, so once I've created the translator, I've given it the language. All we need to do is say translator.translate and give it what we want to translate. Okay, nice and easy. So in here, because myfile.read is going to give us the output that we saw, I'm going to say text equals myfile.read. And simply do the translation equals to, what was it again? It was translator translate. So let's just copy that. So translator translate, and we want to give it the text. So let's see that. Whoop, that's not what I want to do. Let's do text. All right. So if everything works, hopefully it does. Maybe it doesn't the first time around. Let's give it a go. If I run Python 3 script.py, well, we definitely forgot to print here. Looks like we're not getting any errors, which is good. So let's do print translation. Let's run this again. Hey, look at that. Watashi no namae wa Andore Neagoe desu. By the way, I feel like I've been talking a lot and you haven't really talked back to me, but let's get to know each other. I actually learned Japanese before I even learned English. Fun fact about me. All right, let's get back to the topic at hand. This is working. This is actually pretty cool. Let's finalize this by actually converting this file to a translated version. So I'm going to say, I'm going to read this file, and once I'm done with this translation, I'm going to, with open, I'm going to create a new file. Call it, let's say, test-ja for Japanese .text. The mode is going to be to write. And I'm going to say as my file. And in here, I'm going to simply say, or let's do my file 2, so it's not a name conflict, and say simply, let's make this a little bit bigger just so you can see. And in here, we'll just say my file 2.write and write the translation. All right, let's see if this works. I'm going to run it again. Okay. Now, if we go to our desktop, there's a test.ja text, and look at that. We have a translated file in Japanese. I think my name should be in katakana, but hey, this still works. Pretty cool, right? Hopefully you got this far. If you didn't, you see the power of reading and writing files and also using libraries to do different things to your data. Very, very cool. Let's take a break, and I'll see you in the next session. Bye-bye.